Hi guys, today we are going to look at mole-to-mole problems and keep going with our stoichiometry. So, we're going to start with the problem today. If you have 4.67 moles of hydrogen reacting with oxygen, how many moles of water will be produced? Okay, when we're doing these kinds of problems, the first step is come up with a balance equation. Okay, so hydrogen, H2, diatomic molecule, plus oxygen, O2, yields water. Okay, so then we go and balance this, and we put a 2 here, and a 2 here, so that we've got 4 hydrogen on each side and 2 oxygen on each side. Okay, that is step 1. We are going to need that to do everything else. Now that we have our balanced equation, we can move on to step number 2, which is going to be to find the mole ratio we want to use that we learned about yesterday and set up our problem. Okay, so I'm going to look back at my problem and first of all make sure that I know what we're starting with. And we have been told that we have 4.67 moles of hydrogen. So that is my starting information. I'm going to write that down. Now, what we need to do is identify what items we need to include in our mole ratio. Okay? So if I'm starting with moles of hydrogen, I know that that needs to go away. So we're going to put that on the bottom, just like we learned when we have set up dimensional analysis problems for months now. But now I need to look back up into my equation to see what does it want from me? What is it asking? And it is asking how many moles of water will be produced. So I want to switch this to moles of water. So now that we know the substance we're working with, we're going to look back at our balanced equations like we learned yesterday and take our coefficients from the equation and put them into our mole ratio. So, for moles of hydrogen, look at my equation, and I've got 2 as a coefficient, which means I'm going to write a 2 in front of mole H2. Okay, I'm going to do the same thing with water. Look for water in my equation. It also has a 2 this time, so I'm going to write a 2 there. Okay, now it just happens that these are the same coefficients for this balanced equation. You know from yesterday and all our problems we did that that's not the case. So here's our mole ratio and we are ready to move on to step 3. Okay, our last step, step 3, is to cancel and calculate. Okay, so I'm going to bring over our information from the last slide where we set up our mole ratio. And the first thing we want to do is just to double check, make sure that all of our labels cancel out, and see if there are any numbers we can cancel out as well now. So moles of hydrogen on top, moles of hydrogen on bottom, those go away. We've been doing that for a while. That's great. But now we have a new item we want to look for here when we're canceling out. And since with our mole ratios we've added in lots of little whole numbers, since we're dealing with fractions, I can see if I can reduce those, cancel stuff up even more. So here you'll see that we've got a 2 on the top right here, and we have a 2 on the bottom. And just like you know from doing fractions in math, 2 on top and 2 on bottom equal out to 1. So I'm going to cross those off because I don't want to punch any more numbers into my calculator than I have to, because that just means that there's more chances for me to screw things up, or my calculator to screw things up for me. So we want to get rid of as many of those as we can. So in this case, that means that we've actually taken care of all of our numbers. So we have nothing left. So I'm just going to do my calculations now, which means here my answer is going to be 4.67, because I have no other numbers to multiply or divide it by, moles of water. Okay, so that is a mole-to-mole problem for you. We will do more in class today. So make sure you've read the book, that you've done your flip book, and bring your calculator to class. See ya, bye.